Hello everyone and welcome to a new simulation from Science Simulations. In this video series we will start talking about forces, and this is going to be a couple videos for this simulation because it's really deep and it's really fun and I like it, so let's start. This simulation contains 4 sections: net force, motion, friction, and acceleration. In our first video today we will talk all about the net force. So let's say I have this tug of war game and I have the blue team and the red team, and if I put 4 of them here, you can see how much force. The arrows here represent the force, the direction is to the left, and how long is the arrow is how big is your force. Without forces nothing could move, so only with this force we could make the movement. Oh wait, let's return again. Now this time I want to see the value of the forces. So the total here is 350 Newton. What if I have all the other team as well? So this team makes 350 Newton and this team makes the same 350 Newton. So 350 to the left and 350 to the right. Now we used to say if there is no force, there is no change in motion, or you can't get this trolley to move unless there is a force. So is there a force? Yes, indeed. There are 2 forces, 350 Newton to the left and 350 Newton to the right. But if I click go, oops, nothing is changing. It's still in the same place. There is no movement. Because when we used to say if there is no force, there is no change in motion, we actually meant if there is no net force. So the net force is like the sum of all the forces together, because these 2 forces are the same value but opposite directions. We call them balance forces. So they balance each other out, so they cancel out, and the net force is 0. So there is no net force acting here. This is getting cancelled by this, so there is no change in motion and there is no any speed. Now what if I remove this little guy from here? So we have 300 Newton to the right and 350 Newton to the left. Now the sum of forces, or the net force, is just subtracting the bigger one minus the smaller one, 350 minus 300, and because the bigger one direction is to the left, so the net force will also take the direction of the bigger one. So 350 minus 300 is 50, and it's to the left. This is the net force, or the sum of forces. Now since the net force is to the left, what would you expect? You would expect it to move to the left. Let's see. And as you can see, there is change in motion, there is speed, there's acceleration here every second, and then blue team wins. Now let's try another situation. In the previous example, the blue team won, but it took some time, right? Why? Because the net force is 50. So if you want this to move faster, to accelerate more, we need to make the difference between these 2 forces bigger, and that gives me a higher net force here. By the way, when you have different values of these forces, we call them unbalanced forces. So these are balanced forces. Balanced forces only happen when the net force is 0, 2 equal forces but opposite directions. Any situation other than that, whether you have 50 Newton to the left, 100 to the right, 2 forces to the same direction, different directions but different amounts too, anytime you have a net force which is not 0, we call them unbalanced forces. And if we make the difference between them so big, so only this little guy here, 50 Newton against all these 4, 350, that's the biggest difference between the 2 teams. Of course, unless if you make no one here, but let's say I want someone to compete. So 50 Newton to the right, 350 to the left. The net force is 300 to the left. So what would you expect? Let's see. You would expect it to accelerate more. Why? Because the net force is greater. So what do we learn from this section is if there is a net force, there is a change in motion, and the bigger the net force, the bigger the change in motion is. For example, let's say we start with two little guys here, 100 Newton, and this one little guy, 50 Newton, and we start, so you expect it to move to the left, and while it's moving, I added another one here, and it will start changing direction to follow the net force. So at the beginning, it was slowing down, and then speed up in the other direction. Let's try another situation again. So let's say go. Now it's speeding up in that direction. Once we start to make the net force in this way, slow down, and then it's gonna speed up in the opposite direction. How can I stop it? Let's add these. Oh, slow down, but still couldn't win. Now this gets me to ask you a question. So you know that if we have all the team members here and here, we will get sum of forces, or the net force is 0, so there's no movement, right? What if I start like this? You can see it's moving to the left and it's accelerating, and then I added this. Why does it keep moving? Why does it keep moving to the left? What's happening here? If you know the answer of this question, share it in the comments and I will be answering it in the next video. That's it for Forces and Motion Part 1. See you in the second video about forces soon. Pandabood.